the normal distribution. Continuing with example 1, part E. So we want to work out the probability that if a child was randomly chosen from a population that's represented by this normal distribution, that the height of that child will be less than 96 centimeters. So mark 96 on the scale, draw a vertical line going straight up, shade to the left, so we're looking for this region. So menu, option 7, option 2, cumulative normal distribution. Now the lower and upper limits are for the shaded area, and the upper limit will be 96. The lower limit, pick something that's way out on this side, so I'm going to stick with 0, that's a sensible value. So 0, 96, standard deviation was 3, it's a square root of the variance, and the mean is 100 from there. And this is the probability that represents this shaded region, 0.0912. And for the probability of x greater than 96, so a randomly chosen child has a height greater than 96 centimeters, we're shading to the right. These two regions will add up to 1, so we could do 1 minus 0.0912, or we can just use the calculator again. This time the lower limit will be 96, it's the leftmost limit for the shaded area. The upper limit, well, we need to go outside the range of our normal distribution, so something like 500, that will do. Doesn't have to be that 400, 300, they would all be fine. Standard deviation and the mean are still the same, so this is the probability for this side, 0.909 to 3 significant figures. So now we're looking for the probability that a randomly chosen child, so that's one child, will have a height in this interval. So if you press equals after the last calculation, you can put in new values. 97.8 lower limit, 102.5 upper limit. Same standard deviation and mean as before. And this time the probability is 0.566. So part H, so 103, draw a line straight up as before. And then what's the question saying? What's the probability that one randomly chosen child will have a height that's equal to 103 centimeters? So it doesn't say less than, doesn't say more than, so we're not shading to the left or shading to the right. It turns out we're not shading anything. And if we're not shading anything, it's the area shaded that represents probability. Nothing's shaded, so the probability is 0. And that might sound unusual, that we have a probability that's 0, that there's no way you could get a child that has a height of 103 centimeters. But 103 centimeters is kind of implying that you've measured the height extremely accurately. And it's like this. And it's highly unlikely you're going to get a height measured that accurately. So the probability that the height of the child will be something like this will be 0. The thing to remember here is that px equals anything is always 0 in the normal distribution and any continuous distribution. And if we extend that idea a little further to this question, the equals in here is not doing anything either. So we could write this as the probability that x is greater than 103. The answer to this and this are exactly the same, because the probability that x equals 103 was 0. Draw a vertical line straight up to the graph, shade accordingly, use the calculator, lower limit, so on the left hand side of the shaded region we have 103, upper limit, anything that goes way beyond this normal distribution, so 0.159 to 3 significant figures.